What's going on? So this video it's a Reaper script, but it's something very specific to Audiokinetic Wwise. So if you're in the game industry, you may have heard of Wwise. It's a middleware software for audio design. And the thing that we're focusing on is one of the strange quirks of Wwise in that the inbuilt low pass and high pass filters, the values are not given as frequency cutoffs. They're just a value from 0 to 100. So it's very arbitrary. And, you know, I doubt anyone really remembers what the numbers equate to. So it is something that I find frustrating, especially if I know that I want like a low pass at 8,000, for instance. I don't really know where that is. You know, I would guess that it's like, I don't know, 15? But that's just guessing. The point is I don't know. So what we're going to look at today is sort of a translation tool, if you will, a converter that we can run inside Reaper. Because presumably if you do video game audio with Wwise and if you do sound design with Reaper, then you probably have both open at all times. So yeah, that's something that I do. I use Reaper to very quickly convert those numbers in a script, which we'll do together. So just a quick demo. So there's two modes. Wwise value, so like 0 to 100 value to cutoff frequencies, or frequency to Wwise values. So we'll demo both. So Wwise values to frequencies, type in your value, has to be 0 to 100. So let's do 70. And here we go. So filter values of 70. For low pass filter, that's 223 Hertz. And high pass is 7,000. Just one more. Let's do 50. 50 is 1249. That's funny. I thought 50 would be 1,000. Isn't that the most logical? Anyway, yeah, 1249 for 50, apparently. Sure. And the other mode. So let's say that example before, I want a low pass of 8,000. So tell me what it is. The answer is 28. I think I guessed 15 before, didn't I? So I was way off. Shows you how valuable this is. And yeah, for high pass, it's 72. Cool. So that's what we're dealing with. I'm going to delete that demo, and we're going to make our own. So new action, new script in your folder. Wwise filter value converter. Here we go. All right, so we're going to have our main function, which we're going to call at the end of the file. This is where our instructions are going to live. Now, for the first time, you are going to have to somehow get your hands on the data that we're going to use. So I wrote out the values. I found this on the Audiokinetic website. So this is a mapping of the Wwise value to the cutoff frequency. So if it's 0, the cutoff is 20,000. If it's 50, that's one of the examples we saw before. 50 is 1249. And then also for the high pass filter. So I guess I'll make a link to download that little section somewhere. Haven't really thought that far ahead. I'll get it to you somehow. I don't expect you to just copy it all out. That's crazy. All right. Cool. So this data is going to have to be somewhere. Now it's really long. So I think if we put it here, that'll be good, because we don't really need to look at that call function. And just as long as the data is before the call function, because if we put it after, then when we run this function, and then when we're in here in the code will not have seen this table before. Yeah, I can demonstrate that really quickly. This is something that came up in a previous video. So if I move the main to here, and then if I try and reference this, local A equals, if I just try and reference something in the table, attempt to index a nil value, right? So what's happened is, because it goes top to bottom, the script looks at these instructions and goes like, yep, cool, I know what to do, and then it's like, okay, I just read that, I'm going to do what I just read. But this is a reference to here, and the script isn't past this point yet. So it hasn't actually seen this, so it doesn't know what this is yet. So if you're going to reference something like that, it's going to be before the function call. Now if I try and do it, saved and recompiled, that means it succeeded, nothing went wrong. Okay, right. So what are we going to do? So prompt the user, prompt the user for our mode. So we want one to be, wise value to cutoff freak, and 2 is cutoff freak to wise value, and it's going to display both LPF, HPF. Right, so we prompt that. So if mode is 1, then we're going to do the wise value to cutoff freak conversion. Else if mode equals 2, then we are going to do the freak to wise conversion. Freak to wise, that sounds like a disco band. Freak to wise. Feel free to use that. So I guess those could be their own functions. Yeah, that might be a good way to do it. Yeah, wise value to cutoff freak conversion. That can be a function there, which we're going to have to actually, so that's calling the function. So we need to actually declare the set of instructions down here. So if we're in mode 1, we're going to snap over to this part of the code here. And likewise, cutoff freak to wise conversion. And that's going to be its own function there. Cool. It's fairly neat, I would say. All right, so we're going to start with a more difficult one first, which is this. Frequency to wise conversion. But we'll talk about how we're going to do both before we get into the nitty-gritty. But starting with the more difficult one. All right. So we're going to have to, we will prompt the user for the frequency that they are searching for. Convert the user input to a number. Only proceed if that succeeds. We've done that sort of thing before in a previous video. Basically, that's that toNumber function. And yeah, if you have a string that is the digit 5, like a string like this, just the character 5, you can do toNumber on that, and that will give you a number value of 5. So that works. But if you do like a non-numeric string like this, that gives you nil, right? So that's how we're going to facilitate that checking of whether it worked or not. So convert that to a number. All right, now loop through all the entries in LPF table. We've done that before, like a for loop, a pairs loop. Loop through, keep track of which value is the closest to our target. So our target is what the user put in. And we're gonna, by going through each one, we're going to figure out which is the closest to that. And then do the same for the high pass values. Print all of this info to the console log. Okay? All right. Yeah, let's get into it. Let's do it. So, prompt the user for our mode. Yeah. All right. Let's start there. So let's get user inputs. We've done this before. All right. So there's like a success boolean, which I don't think we really need. Remember, one of the things you can do, like sort of a convention, is if you call a variable just underscore, that's sort of convention to mean that, yes, we're storing a variable called underscore, but we don't really care what it is, and we don't intend to use it. So that's what that underscore means. We have to put something in here because this function returns two values, and they're in a specific order. And the one that we really care about is this one, right? And it has to be second, separated by the comma. So we actually need something here, and that's where that underscore comes in. It's sort of it's a variable that we are telling ourselves that we don't care about. So that's the mode, right? String title. This is sort of our instructions. So one is, what is it? wise to frequency. 2 is frequency to wise. Number of inputs is 1. More instructions, type 1 or 2. And needs to start off as empty. Let's see how we go so far. Cool. So, yep, that looks good to me. And then we choose our option. Cool. All right. So now we need to convert to, convert mode to a number. Because at the moment it's a string. Like if you type in 1, it's going to currently be this sort of thing. So it's a string with a single character, and that character is the number 1, but that is not the same as a number. It's a different data type. All right, so we do that by toNumber mode. So we're overriding mode with the outcome of this function. Yeah. And then we're using it to check here. So just to point something out, if we type letters in, we don't get an error because it's trying to do this toNumber thing. And remember that's going to be nil if there are non-numeric characters in there. So then when it does these checks, both of these will be false because this will be nil. It's not 1, it's nil. It's not 2, it's nil. And then it gets to here, and then we finish the function. So that's how that works. We don't need to put in any additional checks there like we do in some other examples. Okay, cool. So yeah, let's focus on the more complicated one, which is frequency to wise value. All right, so we need another prompt. So we can copy. All right. So frequency search, is that a good name for it? The frequency that we are searching for. That's what that is. Type your target frequency. Sure. How does that look? Number 2, type your target frequency. All right, cool. So we got our frequency search. So we're going to loop through all entries, all entires, all entries in LPF table. Keep track of which value is the closest. All right, so we've done something similar to this before. And the way we do that is up front, we declare a sort of like a running variable that we update throughout this loop with new values as we get closer and closer to the target value. So closest frequency. So we're going to declare that with, what we're going to do is we're going to start off with a really big number, because then in the first iteration of the loop, that first number will be closer than this ridiculous number. So straight away, the closest frequency is the first one that we look at in this loop. And then from then on, it's doing real checks. And the way that we make a ridiculous number is math.huge. And I think that's the biggest number supported by Lua. I think that's what math.huge is. But yeah, it's a good way to do it because, like I said, the first time we check, it'll beat this one straight away. So it's already winning. Cool, so we need that. And then we need the closest wise value. So that can start off just as nil. We're not comparing anything. Because what we're doing is we're looking through these, right? We're looking at this right-hand column. And let's say we type in 2000. This might be the closest, and then it sees this one that's a bit closer, and then we eventually get to that one, which is the closest value. So that will be the closest frequency, and this will be the closest wise value. So yeah, we're going to store both those, the left-hand side and the right-hand side. Right. So how do we do this? So this is one of these ones. So we have done this before. I actually can't remember what the context of when we did this. I remember we did something when we did the color script. That was an example of using a key value pairs for loop. But yeah, just a brief explanation. What we're doing is we're declaring 2 new variables, and they're different each time we do the loop, right? Every iteration of the loop, these are different values. So k, it doesn't have to be k and v, actually. That's just something I do because it's key value, k for key, v for value. But you can do anything. What we could do is we could do w and f. W for wise, f for frequency. So what this is referring to, w is the left-hand side, f is the right-hand side. So it's going through that LPF table, looking at each pair, the wise value, frequency value. And then we don't have any instructions yet, but on those pairs, we can do stuff. And the stuff that we are doing is we're comparing to this. So compare f in each iteration to closest frequency to see if it is closer. And if it's closer, then we update closest frequency with F, because that is now the closest. All right, so how do we do this? Cool. So difference between closest, current closest, and target. That is a big variable name. How can we make that shorter? Diff between current closest and target. Yeah, whatever. That's fine. It's a very big variable name. That's fine. So difference between would be closest frequency minus frequency search. So that's our target. Okay. Now, just a little caveat about this. If closest frequency is bigger than frequency search, then yes, this will be the difference. But closest frequency might be smaller than this, in which case we'll get a negative number. So that is not a great way to go. Luckily, there is a solution. We can then update this with math.abs, which is short for absolute value. Math.abs, these are just notes for you. Absolute value gives the positive magnitude of the value. Okay. For example, math.abs of 5 will equal 5, no change, but absolute value of -5 will equal 5. So it gives the positive magnitude. So what it's doing here is, it's giving you the difference, regardless of whether it's negative or positive. So that's exactly what we want, giving you the difference. Cool. And yeah, difference between this frequency and target. So will be this. And we can do this on one line. We can go up front, absolute value F minus frequency search. F being the frequency that we're looking at in this loop iteration. Okay. And now check which is smaller, meaning closer. So if this one that we're looking at is less than the current closest, then the current closest is now the one that we're looking at. And when we're every time we update that, we also want to update the Wise value. So we also want to update the Wise value at the same time, and that's going to be W. Because remember, W and F are pairs, they're joined at the hip, right? So when we're in this iteration loop, W is attached to F. For instance, if that F that we're currently looking at is this number, then W is this number. So as we update this on closest frequency, we update this on closest Wise value. Cool. That's good. Let's just see if anything crashes. No? All good. All right, so we're going to have to do the whole thing again, but let's just quickly make sure we're sort of on the right track by printing out the value. So that is console message. Message. All right. So we'll build our message here. So looking for, and remember when you have a string and then the two dots, that's a string concatenation. So you can join two strings together. So looking for concatenated with frequency search, concatenated with hertz, and then Y's LPF value is closest Y's value. And that's it, I think. All right, let's try it. So let's look for 7,000. Closest Y's value is 30. Let's just check if that's correct. So we looked for 7,000. Ah, exactly 7,000. What are the odds of that? Okay, let's, bloody hell. Let's do another one then, because we want, let's do that, 5400. Where'd you go? All right, so looking for, oh, we need a character break because that's our new message. This is our old message, but we can do that in a sec. So we're looking for 5400 and it's given us 33. So yeah, there you go, very, very close. Cool, so let's put in a character break. I don't expect you to remember that one, but it's this guy, /n, and we might do 2 actually, so that'll do 2 character returns. 2000 gives that. Nice. Let's do one more. 1000 gives that. Sweet. All right. Cool. So we might break the video here before handling the HPF version. What I'd encourage you to do is give it a go before watching the next video. You know, we've seen how we would do it for the LPF. The HPF is pretty much the same, but it'd be good practice just to go through and give that a go. And then you can also give this one a go, option number 1. This is actually much, much more straightforward. So yeah, attempt both of those things. And if you get stuck, you can jump on to the next video. So maybe I'll see you there. Thanks.